Oh, thanks everyone for joining today. As Wayne sort of emailed out, we're doing a presentation on a new product called Cleanair-Sky, which you might have seen a product release for about a month ago, but it's a little bit different to what our standard products are. So we thought it'd be worthwhile doing a bit of a training session on this and sort of going through a bit more of the ins and outs of how it works, just to make sure that you're all sort of comfortable in the product and how to sell it, I suppose. We're going to start off talking a little bit about ventilation and COVID transmission in buildings, and then we're going to sort of lead into air purifiers like the Cleanair-Sky and sort of how they will work, sort of thing. But yeah, like I was saying before, if you've got any questions, just unmute yourself. Feel free to jump in at any time. Otherwise, we'll take some questions at the end as well. But we'll get going. Okay, so where this product has come about is obviously we're all sitting in the middle of COVID-19 and we've all been in the middle of this, and we know that COVID-19 is an airborne virus, and there are ways to actually reduce the concentration of COVID-19 and other viruses by using better ventilation. And we know that the best way to reduce airborne transmission risk is just to increase the amount of ventilation that we're providing to a building. So I was at a conference last Thursday and Friday done through AMCA, and the whole conference was on airborne transmission of COVID-19 and what we need to do about ventilation rates. This is well known in the industry. We just haven't kind of figured out how to handle it yet, I suppose. But we all know it's a problem and we need to do something about it. So we're going to start talking a bit about ventilation, and then we'll go on to air purifiers. So first of all, really basic stuff. What is ventilation? We talk about we provide ventilation equipment. Ventilation is just bringing outdoor or fresh air into an area. That's basic terminology for ventilation, bringing fresh air into a building. So if you're recirculating air, we wouldn't normally call that proper ventilation, but bringing fresh air from outside where it's clean is ventilation. And the reason we ventilate, the reason we use fans, I suppose, in buildings is to mainly reduce the carbon dioxide levels in a building. So if I'm sort of, I've got a little 2 sensor here, and you can see here that I've got 871 parts per million of CO2 in my office at the moment. So I'm breathing out carbon dioxide, and we've got a ventilation system in the building which is doing something, and based on the amount of ventilation and the amount that I'm breathing out, we've got that sort of carbon dioxide level in my office, which is fine. But it's important to understand that's what we're doing. We're actually reducing CO2 levels in environments. Everybody breathes that CO2. So when we look at ventilation rates from like standards like AS 1668.2, and they say we need 10 litres a second per person, or we need 25 litres a second for a fixture or whatever, they're generally about trying to reduce CO2 levels. We don't think of it like that, but that's kind of what we're trying to do when we're having those airflow rates. And what it's actually trying to do is actually trying to achieve 850 parts per million. And like I'm saying, here I'm 870 at the moment, sort of thing. So I'm just above where it probably should be, but it's in the ballpark, sort of thing. So it shows that our ventilation system's probably working okay because the CO2 levels are reasonable in my office building at the moment, in the office room. So why do we want to reduce CO2 levels? So ironically, if you look at all the ventilation standards we've got, the way they're written has actually got nothing to do with health. It's about body odor. So if you look at 10 litres a second per person, it's around sweating and sort of body odor and making it smell more comfortable. That's what they're all actually written around. They didn't think that CO2 was actually an issue. It was just about if we had a classroom full of teenagers, we don't ventilate it, it's smelly. And so that's what all of our airflow rates are based on. So it's a pretty, it's just telling you as it is sort of thing. But what we're now discovering is that, well, it's not just odor, which is actually where we're helping with. CO2 levels actually affect other things. If I have very high CO2 levels, it reduces concentration, it makes people drowsy, and can interrupt your sleep. So So here's a graph. You don't have to understand it, but basically, if you just look at the green bars here, so what it is, it's basically they set up this laboratory and they had people do certain tests, and the bars are just saying what the score is. So the green bar here is saying if I've got normal ventilation, I've got a score of 1. When I double the ventilation rate, so I reduce the CO2 level, I've got a better score in my test. And so they tested on various different things, whether it's basic activity or tasks or crisis response. And every single time, as they increased the amount of fresh air coming into the room, people's test scores got better. Now, this isn't schools we're talking about, this is office buildings. So basically, if we put this into perspective, the green line here is 10 litres a second per person. So that's kind of what AS 1668 asked for. The green dotted line, which is a better ventilation, is 20 litres a second per person. So by doubling the amount of fresh air in your building, you actually perform better. You get better scores in tests. And so this is actually testing how well you're performing in your job. So you get a productivity bonus by having higher ventilation rates. So that's something. Here's a bit from the Building Code of Australia, which says, okay, this is what amount of CO2 you should have in a building. 850 parts per million over an 8-hour time period. So while mine was 870, average over 8 hours, it's probably fine, sort of thing. Okay, that's all good. But what happens in reality? I've got these little CO2 monitors, which a number of you would have seen in the past, and I've done a few experiments at home. So I've given it to a few people at Fantic, said, right, take this at home, put it in your bedroom overnight, and it records the levels over time. And so I recorded these levels, and one of the employees here at Fantic, the levels got to 5,000 ppm in the bedroom overnight. Now we're supposed to achieve 850. So we're 5-6 times the level of what we're supposed to be. We're actually getting to really unsafe levels at those sorts of levels. And the reason was he had no ventilation in his room. He's in an apartment building. There was no windows to open, and just assume that the apartment had good ventilation, sort of thing. It had terrible ventilation. And so now he's got to do, okay, what do I got to do to actually try and improve the conditions? I did it in my own house. My bedroom might have been 1,500 parts per million. I now sleep with the window cracked open a little bit, and that brings it down to about 700, and you get a better night's sleep. So again, CO2 levels affect how we actually sleep. So it's actually important for all of us. So increasing ventilation reduces the CO2 level. It also helps reduce the risk of transmitting viruses in the air. And that's kind of what we're really trying to focus on at the moment. But ventilation is important for lots of other things as well that we don't sort of talk about very often. So when you think about what's typically in a house, you might have some split system air conditioners. And the general thought process is, oh yeah, I've got some air conditioning, that's ventilating my house. But it's not. A split system just recirculates the air in your house. So your CO2 levels don't get better. It might be nice and comfortable, it might be nice and cool in summertime, but your CO2 levels will actually be very high. And we've got a split in our house sort of thing, and so I've tested that as well. Yeah, it just goes through the roof unless you can have some fresh air coming into the house. Okay, so back to the first slide. The best way to reduce the risk of airborne transmission of viruses, such as COVID-19, it could be cold or flu or whatever it is to increase your ventilation rate. So what have we got available? We've got two things we can do. We use mechanical ventilation or natural ventilation. Let's start with natural. Now, natural ventilation, I don't know about you, I was never quite sure what it actually meant, but open the door, open a window. That's natural ventilation. It's just letting fresh air in from outside. It's really simple. So obviously we can do that in most environments. Lots of buildings, apartments might make it tricky to do this sort of thing, but yeah, it's a really easy thing to do. It's cheap, and it can be really effective, but it only works well when it's windy outside or the temperature conditions are right. So we call this uncontrolled ventilation. So if it's a nice windy day, brilliant. I've got tons of ventilation, tons of fresh air coming in. My risk of transmitting COVID or whatever it is going to be very low. That's why the governments have told the schools to open windows and doors because this is the best way to sort of stop COVID transmission. Now, it might be great on a 23-degree day, but what if it's 40 degrees outside and you open a window and a door? Now everybody's actually absolutely stinking hot sort of thing because you're just bringing the temperature inside. What if it's 8 degrees on a cold winter's morning in Canberra or whatever it is, or in Melbourne? Well, okay, it works, but it's not suitable under all circumstances. And again, if we open a window or a door and you've got an air conditioning system, well, the air conditioning system's not going to perform properly. It's not going to be able to handle the actual heat load because you've actually let all this outside air in. So you kind of just killed your air conditioning system as well. It introduces noise. Like I said, I crack open the window in my bedroom now. Of course, when a truck drives past or something like that, you hear it. And so while the air quality is good in my bedroom, that's the downside to doing that sort of thing. I probably need to put a fan in. That's probably the solution, and sort of do that. Dust and pollution can enter a room as well. So these are the downsides to natural ventilation. It's a cheap and easy way to do it. It works effectively on the right conditions, but there are various reasons why it may not be suitable. And again, the reason for this, for going for this, is because this is what the governments are telling us to do, particularly in schools. And this Cleanair-Sky product is mainly designed around school classrooms. It can be used elsewhere, but that's its primary function. And this is what the governments are saying to do to schools. But these are the disadvantages to actually relying on that advice. Okay, so now we go to fans, mechanical ventilation. It's using a fan to bring fresh air into a room for consistent or controlled performance. If the fan does 100 litres a second of air, it's bringing in 100 litres a second of fresh air all the time. You don't have to worry about the wind conditions outside. It's consistent. Obviously, we still are bringing the outside air in, so it's going to be affecting your air conditioning and heating. So again, you've got to make sure that your air conditioning and heating system can handle that. But you can size things to deal with that. Obviously, you can bring noise from outside, but you can also have noise from the fan as well. So you've got to make sure we select them properly, which we're all good at doing. And again, we're still bringing outside air in, but we can put a filter on it if we want to make sure we're not bringing in dust and pollutants from a busy road next door, for instance. And we need to make sure we have inlet and outlet openings in a room. We can't just put a fan in, exhaust the air out. We've got to have a way for the air to come into the room to replenish it, sort of thing. So we all know these basic things, but again, it's not always as simple as just put a fan on the wall and you'll solve the problem. Okay, so ventilation is great, and ventilation it is the best way to actually help with reducing virus transmission. But in many cases, it may not be suitable for an environment. And if that's the case, then we would look at using air purifiers. So again, fans are always going to be the first thing we try and sell. And that's our primary function. But if it's not suitable to go and put increased ventilation in, then we can use this as an alternative. Now, the one thing is we're only recirculating air, so we're not reducing CO2 levels. So all those things I was talking about before, we're not helping with this type of product. But we can reduce the virus transmission by using these types of products. So here's the catalogue pages for the Cleanair-Sky. And you would have seen this probably about a month ago, so I'm not going to go over too much detail, but basically we've got the unit here. The air comes in through the bottom and gets discharged horizontally. It's mounted on the ceiling, and we'll go through the details during the course of this presentation. So here's a bit of a cutaway from the release that we did, and we'll talk about the product a little bit and how it works, because it's just a little bit different to a typical fan. So what we have here, we have a number of filters attached to our mechanical unit here. And so we have a pre-filter on the inlet. This is what's called a G4 filter, and it's just designed to get rid of large particles such as dust, dandruff, or hair, for instance. So it just gets rid of those big particles that might be otherwise sucked through the unit. And it's more there to try and protect the rest of the unit, so we're not actually having high maintenance and costs there, sort of thing. So we'll explain as we go through. Once the large particles have been removed by that filter, we've now got our plasma and our fan in this box above it here. And so what plasma is it's a plasma unit, just a small box effectively with these electrodes which go past it, which produces a high voltage. So as air passes through it, some of it turns into what's called plasma. Now, I won't go through the definition of what plasma is, sort of thing, but the plasma deactivates viruses and bacteria. It can eliminate pollen. It can reduce odor as well. So by creating that high voltage and turning the air into plasma with this unit, we can actually get these additional effects occurring. It does produce certain contaminants inside that area as well, which we need to be careful with, and that's why we have the other filters in the system. Then we have post filters. So we've got what's called an F9 filter here. And the F9 filter is just to get rid of any really small particles and just to make sure the carbon filter at the end doesn't get loaded up with other bits and pieces. We're just trying to protect this to make it work. Oxitec, actually, who make this product, did tests with and without this F9 filter. It didn't change the amount of virus reduction we got. It's not there to actually help with virus reduction. All it's doing is actually protecting the carbon filter. So you can actually take that out. The unit would work perfectly fine, but it does protect that filter, so we keep it in there effectively. Actually, the only thing that fine, I don't need to go into that. And then the carbon filter at the end, what it does is it captures any odors and converts any ozone that's inside the unit, because one of the things that can be created from this plasma process, it can turn the air into a couple of different contaminants. It can create ozone, which you don't want in the air. So the ozone is a negative thing, but having the carbon filters on the outside here stores that ozone. Ozone only stays live for a short period of time, converts back to oxygen, so only clean air escapes. So you wouldn't run the unit without these carbon filters, because then ozone could escape. But with the carbon filters on there, you've got clean air which actually escapes out of there. So it's important to make sure that we have the filters in the unit so that only clean air gets out of the unit. Now, since the Cleanair-Sky is just recirculating the air inside an environment, we're not affecting the existing ventilation, heating, or cooling. So you can just put it into any room, and it's not going to affect your mechanical ventilation system, your air conditioning systems you already got there. So it's not like putting a fan on a wall or opening a window sort of thing. We don't have those negative consequences as a result. Okay, so let's talk about sort of some of the examples of what it actually does. So the one thing the Cleanair-Sky will do is actually will help render pollen sort of inactivate pollen. So here's a photo here of pollen under a microscope, very small particle, 10 micrometers, and that's untreated. After it's been through plasma, that's kind of what it looks like. So it kind of damages that pollen and means that it's no longer as harmful as it was previously. So it does the same with mites and animal hair as well. So if you're thinking about people who might suffer from allergies or hay fever or even asthma sort of thing. Now, while we can't say this will reduce your asthma, this will reduce your hay fever. It's not quite like that, but some people are triggered by pollen. And if we're then reducing the pollen, well, that may help in that particular case. So it will help in numerous cases, but it will not help everybody, because everybody is going to be affected by different triggers with those particular sort of diseases, I suppose, or symptoms. But it can help under those circumstances. It may help asthma sufferers, it may help hay fever, but it really comes down to the individual person. So there are benefits here, though. So certainly there'd be some interest in that. It helps reduce mold and bacteria. So if you think back to your old science days, if you paid attention, long time ago for me, but here's a petri dish, and a petri dish is just a dish in which they grow bacteria or germs. And so what they've done here on this left-hand side, top left-hand side photo, they've got E. coli, which is a form of bacteria. And then they've exposed that, and those red dots you can see here are the actual E. coli bacteria. On the right-hand side, top right, is after being exposed to plasma for 60 minutes, and you can see all the red dots have gone. So it's gotten rid of that in a relatively short period of time. The one below is what's called black mold, or Aspergillus niger, but black mold is a common term for it. And again, you got these big black dots on the left-hand side, and there's less of them on the right-hand side after 60 minutes. So we've actually reduced the amount of mold concentration in the air. Now this is not going to help if I've got a bit of mold growing on my shower wall or something like that, because it's got to go through the unit in order to actually be deactivated. But the mold that comes off that shower wall and then gets moved through the air and you might be breathing in, that's what it is reducing the levels of. So it is actually important, and it is actually helping with the air quality in your bathroom, for instance, if you put this there, but it's not actually getting rid of the mold on the wall. Virus reduction. Now, it also can inactivate COVID-19 as well. Now, if you look at our press release, we don't talk about it deactivating COVID-19. We say it deactivates viruses. And the reason for this, and this test was done by a place called the Fraunhofer Institute in Germany. And this is what the test looked like. So they had two Cleanair-Skys in a laboratory here. The laboratory has actually been sized to match a classroom. So again, everything for this has all been made around classrooms. And so they've got a device in the middle on this stand here, which is putting virus into the airstream. They got some measurement devices which are measuring the virus levels over time, and then they got some devices. And this is a 211 cubic meter room, so it's again designed to be similar to a classroom. What's about 8.5 by 8.5 meters by 3 meters high. And then they've also gone and done similar tests in a real classroom. So again, the whole thing here, and what we've got to bear in mind, is a lot of units you see on the market have been tested, but they haven't been tested in the same condition that we're talking about. This has been tested in the same sort of environment, and that will explain things as we go along. So this Fraunhofer Institute is sort of like CSIRO in Germany. It's a top scientific organization in Germany. Obviously, we don't know it here, but that's its function in Germany. And the unit was placed in a real room, like a typical classroom size, to determine the effectiveness in the environment. So it's not just saying, oh yeah, the Cleanair-Sky, if I just pump viruses directly into the inlet, how effective is it? It's saying, no, if this room is filled with viruses and the unit is just recirculating air in that room, how long is it going to take for the virus levels in that classroom to reduce? So it's different to saying, oh, I'm just pumping air through the plasma unit. It's actually, no, I'm looking at the virus concentration in the classroom. And so what they did is they tested a virus, which is called a surrogate virus, which is identical to SARS-CoV-2, which is the virus that causes COVID-19, in structure, size, and stability. So this is the virus you'd use for COVID-19. The issue is you can't just go, oh, let's go and pump a room full of COVID-19, and then we'll go and test it. It's not terribly safe doing that. And you need a huge biosecurity sort of chamber. It would cost millions and millions of dollars to do that sort of test. So while in theory it's possible, but the cost would be astronomical. So what they do is they use a virus which is not as infectious as COVID-19, but has the same physical properties as COVID-19. So that they've shown that this is as hard to kill as COVID-19. It's the same size and everything like that. And what we've found is inside that room, so again, not through the plasma unit, but inside the room, the virus level dropped by 97% after a period of 165 minutes. Now, one thing I'll sort of point out here, you might go, oh, but I see other units which say they can do 99.99% reduction. But this is not the unit itself. This is saying this is what the virus levels in that classroom happened over 165 minutes with the air movement patterns and the air going into the Cleanair-Sky, not just pumping the virus directly into the unit and going, oh, look how good we are. We've actually gotten rid of it. We're actually testing it in a real condition. And it's actually underestimated because they hit the test limit. They can't test any more than 97% reduction. So that's as high as they can publish. But that's the maximum that they can record under this particular test process. The test was conducted at speed 3. This is an EC fan. It's a 4-speed fan. So this is the third speed. It's sort of equivalent to a typical split system air conditioner in your house sort of thing. So, or an air conditioning system in your building. You hear it whirring in the background. You can certainly hear it, but it's not objectionable. And therefore, we're not testing it at maximum speed so we get the best result. It's under realistic test conditions. So why I'm explaining all of that, because this is not how our competitors to this product would test. They don't test in real life situations. So we've tested in a simulated classroom, or Oxytec, the supplier has. Competitors might test in a 28 cubic meter room. That's the typical standard room size for an air purifier test. We're 8.5 times bigger than that. It's going to take longer to do stuff in a room that's 8.5 times bigger than if it's only 28 cubic meters. Sometimes they just expose things to a Petri dish, like we were talking about before, or they test it in duct. So everything is making sure that we're directing the contaminant towards the unit and so we can get the best possible result. But when you're testing in a real environment, you don't have those advantages. Competitors will test at maximum speed because you get the best result, but it's noisy. So we've tested at a reasonable speed. We've tested a virus which is comparable to COVID-19. A lot of people just test smoke or dust, salt water, or small particles. They're not actually testing against a real live virus. So you don't get the same effectiveness, I suppose. It may be more effective against those particles than it is against COVID-19. We're testing the unit in isolation. Now, what can happen if you've got a room which has got COVID-19 in it? Let's say I've got a wall here, for instance, and I've got a virus particle which is moving around. It hits the wall, it sticks to the wall. Therefore, that's no longer in the air. So when we're saying how much reduction of COVID have we got in the air, well, any particles which hit the wall can be considered as being taken out of the air. And the unit's not doing that. The Cleanair-Sky, the plasma's not deactivating that virus. It's just sticking to the wall, it's sticking to your table. But again, a lot of test processes don't account for that. They say, oh yeah, what's the reduction of the virus? Oh, wonderful, we've got a 99% reduction, but you might be testing other things other than the unit itself. Also, viruses die over time. So if the virus takes 2 hours to die and you're testing for an hour, 50% of the virus could be gone just because you've tested over a period of time. But this unit has only been tested for the unit only. The decay due to hitting surfaces and the decay, which is the killing off the virus, has been taken out. It's purely what the Cleanair-Sky does to it. So we're using very conservative results. A lot of competitors use very optimistic results under non-real conditions. We've also got test reports which shows how it performs against VOCs. So VOCs are something called volatile organic compounds. This is sort of like the fresh car smell you have in a new car, or when you move in a new house, the paint smell or the carpet or whatever. These are things which might smell good in some cases, they're actually bad for us. So the Cleanair-Sky has been shown, it's been tested against a whole heap of these chemicals, and it shows to reduce the levels of lots of them. Also reduces odor. So again, we're talking about body odors before. So a school classroom would be a good example of a room full of teenage boys, or cooking. So you have it in an area where you got cooking, well, it can reduce the actual odor from the cooking process. No byproducts such as ozone, aldehydes, ketones, or other chemicals were released into the room air. Like I said, inside the unit, yes, it does create some of those products, but the testing showed that actually wasn't released into the actual air, which is important. Okay, so now let's sort of talk about the features of the product. So the Cleanair-Sky needs to be installed by an electrician. You might go, oh, that's why can't I just get somebody to buy it and sort of have a plug and lead on it? It's actually a positive point. And the reason it's a positive point is that what do our customers do? They install things. Now, if we're talking about a school, for instance, we say, oh, listen, yeah, just go and buy an air purifier with a plug and lead on it. They can just go to Harvey Norman, go and buy an air purifier themselves, cut the contractor out, and do the work themselves. So our customers don't get any sale out of that. So they need to be able to install a product. So actually, this is actually important. It actually is something we wouldn't want to be selling as standalone air purifier, because who's going to buy it from us? Our current customer base doesn't buy those types of products, because the end user will buy that. It's relatively lightweight, 13 kilos, so it's easy enough to sort of lift up and install. Now, the big point here is it doesn't draw virus from person to person. It draws the virus towards the ceiling because it's ceiling mounted. So what do I mean by that? So here's a very crude diagram here showing an air purifier on the left-hand side of the room and a person who's got cold or flu or COVID, whatever, on the right-hand side of the room. So we've got an air purifier at one side of the room. It sucks air in horizontally and then discharges air out. Again, that's great. The air that it discharges will be clean. That will work perfectly fine. But it's drawing air, contaminated air, from this person who's infected to a person who's not infected. And so it actually, while it's designed to clean the air and make the area safer, because of where they've positioned this air purifier, it's actually potentially causing virus transmission. So any floor-mounted unit, unless you position it really carefully so there's no occupants between the infected person and the air purifier, it's going to drag that air across other people and particularly infect them. So that's the big fundamental problem with the typical air purifiers. They work, but this is the fundamental issue. A ceiling-mounted unit like the Cleanair-Sky, it draws air up towards the ceiling. So therefore, if somebody is contagious, they breathe or cough out, the air is drawn towards the ceiling, but it's not drawn across other occupants. So you're reducing the risk of transmitting that to other people by drawing it towards the ceiling. So having a ceiling-mounted unit is actually really important. Okay, so more about the product. So it's quiet. Like I said, speed 1, you can't even hear it running sort of thing. Speed 3 is very, very acceptable. Lightweight and easy to mount. Low running costs, 39 watts of power at speed 3. So again, very low electricity cost. Got an EC fan, 4 speeds as standard. So speeds 1 to 4. It deactivates viruses, bacteria, and germs, as we talked about. Renders allergens such as pollen, mite, animal hair harmless. Again, allergies to animal hair, all that sort of stuff. Reduces odors and remote control. The unit can run at high speed when the room's unoccupied. And we're going to run on time to clean the air once the room is empty. But we'll go through that now, sort of thing. So let's first look at the unit. So air intake through the bottom, discharges through the top at ceiling level. So that's sort of how the system works. The remote control, and so that run on top of the function I was talking about. So this is what you get with the unit. So it's sort of like an Apple TV remote if you've ever seen one of those. Just a bigger version, that sort of thing. Not that big, but yeah. So what the functionality of it is, you've got a plus button, a restore, minus, and pause effectively. The plus button just increases the speed. So if it's off, press it plus, goes to speed 1, speed 2, speed 3, speed 4 minus, speed 3, speed 2, speed 1, turns it off. The restore button starts the unit at the speed at which it was switched off. So if we've got it set to speed 3, because that's the level which was appropriate, and we press restore, it just switches it back on to speed 3 if it's turned off. Press restore, switches it off. Press restore, switches back on to speed 3. So whatever it was turned off at, that's the speed that it restarts at. The pause or boost button here runs the unit at maximum speed, speed 4 for 10 minutes, and then returns to the previous speed. So again, let's say it's a classroom, because again, it's all designed around the classroom. You get to recess. and you want to make sure you have a bit of extra air cleaning during the recess time. You don't worry about the noise because there's no one in the classroom. You press the pause button. It boosts it to full speed for 10 minutes because that's sort of how long recess would last for. Then it switches back to where it was previously and then keeps on operating. So these sort of smarts are kind of already built into it. To switch it off, minus button to hit speed 0, straightforward. We can press the menu button. The menu button is a run-on timer thing. So what this is designed to do at the end of the school day, as an example, you press the menu button, it switches the fan off after 30 minutes. So it's like a purge. So we're actually saying any virus which is left in at the end of the day, we want to make sure that we get rid of that before we start the next day sort of thing. So it just runs for another 30 minutes after the end of the day, switches itself off, and then it's ready to restart again at that predefined speed and restore, like we said, saves the speed, switches off, saves the speed we're talking about. So it's quite clever in what it's done, that they've thought it through really well for a school environment. Now, while we've got the remote control here, we've also got a display on the side of the unit, which you can do most of the functions there. We've got the menu, minus, plus, and pause. Obviously, you're not really going to be playing with this because the unit's mounting at ceiling height, so you kind of have to get up onto a step ladder to get to it. But you've got a display on the side here which tells you what speed it's operating at, whether it's 1, 2, 3, or 4. It can also show you error messages as well. There is some maintenance required with this unit. So as we were saying before, we've got various stages of filtration. We've got the pre-filter on the inlet of the unit. This is replaced every 3 to 6 months. So again, we've got pricing on all of this, and I'll show you how to do this in a second. The post filter and the activated carbon filter, the two filters on the discharge of the Cleanair-Sky, typical replacement time is 5 years. So it's very long life. It's about 9,000 hours, but 8 hours a day, 5 days a week in a classroom is about 5 years time sort of thing. So it's actually quite a long replacement time we're talking about. There's just a list of the error messages that we've got on the side of the unit. It tells you if the fuse is defective, if the fan's got a malfunction, if you need to change the activated carbon filter, and if the filter is not mounted correctly. So it's got some error messages there which give you some sort of warning if there's a potential problem. So changing the filter, like I'm saying, only the pre-filter, this filter here, that needs to be changed regularly. There's just, I think, some thumb screws on the actual, I got too far. On the bottom panel here, on the sides, you can see 2 screws. You just undo these screws. The unit's hinged. It drops down, and then you can slide this filter out, slide the new filter back in, tilt it back up, thumb screws back in. It's a very simple sort of replacement job. You don't have to sort of have any special equipment or anything like that. It's not complicated to do. With the actual post filter and the carbon filters here, what you've got on these discharge louvers here, they're screwed in sort of things. You need to unscrew those, pull the actual discharge cover off, take the filters out, replace those, and then put it back in place. There is an automatic switch off safety switch here, which is a limit switch. So when the filters are removed, the unit can't run. So like we're saying, we need the filters there because it will produce some ozone inside the unit, which we don't want getting out. So there's actually some safeties in here which actually stop the unit from operating if the filters aren't installed. So we've actually got those safeties in place. Okay, so what are we comparing against? We're comparing typically against sort of floor-mounted HEPA or floor-mounted air purifiers. And so like we talked about before, the big weakness is the floor units draw viruses across the room and therefore across other occupants towards the air purifier, and therefore we're risking virus transmission. If it's a UV unit, the lamps are expensive to replace. Again, they've got a certain lifespan, but I mean, it depends on what brand lamp you use as to how often you need to replace them. There's a risk of exposure to UV light, so it's just about making sure the unit's made properly. HEPA filters are excellent. I mean, hospitals use HEPA filters. There's no question that HEPA filters are excellent at getting rid of viruses. That's what they're designed for. But some air purifiers, you look at some of the cheap stuff on the market in particular, they'll just go, oh, we've got a HEPA filter in it. But they have no other form of filtration in some cases. So while we've got these two filters or beforehand, before the carbon filter, if the HEPA filter's got no pre-filter, all the dust just gets clogged up in it. And all the animal hair and everything like that, and things which you should be sort of filtering out, can now just get clogged up. And that HEPA filter is expensive to replace. So you might need to change your HEPA filter every 3 to 6 months. So, of course, that becomes very expensive. You kind of need pre-filters to protect your HEPA filter. But some of the cheaper units wouldn't have that. The expensive ones do, but the cheaper ones may not. HEPA filters have a high pressure drop. Therefore, they need a high fan speed to work. So it makes the units noisy. So if you've got an air purifier with a HEPA filter, it's typically going to be noisy if it's going to be working effectively. And of course, as the HEPA filter gets dirty over time, because all filters get dirty over time, it has a higher pressure drop, which makes the fan run even faster. So while new, it might not be too bad, in 2 or 3 years' time, it's going to get worse and worse. You need to make sure you seal the HEPA filters really well if you want them to work. Otherwise, they just don't work properly. They're expensive to replace. And one thing which a lot of people don't think about is we're talking about putting all these air purifiers in rooms to get rid of, say, COVID-19. Well, what if there was COVID-19 in the room? And then you decide, oh, I'm going to go and replace that HEPA filter. Well, the virus doesn't just die instantly. It can survive for days. On surface, it can survive for maybe 2 weeks or something like that, 3 weeks. So you might think, oh, yeah, it's all pretty safe. Go and sort of take the HEPA filter out, go and replace it, and that's contaminated. So you've now just gone and released the viruses back in the airstream, or you're breathing in the virus. So you actually have to be really careful because of what we're trying to do here. You really need to have protective suits in order to replace HEPA filters. So it's not quite as, people don't kind of think about that thing, but it's removing viruses which stay alive. And the last thing is that with a floor-mounted unit, they can be easily damaged. Put it in a classroom, kids are going to kick it or whatever sort of thing and sort of bump into it, takes up floor space, and it might be a trip hazard. You've got to plug and lead, obviously, sort of thing. So it's a less expensive option. It's certainly not without its disadvantages. So yeah, mobile units are going to plug and lead. End users can buy them themselves. Our customers want to install units, as I mentioned before. So again, we want to be supplying at least something which requires an electrician to install. Otherwise, it can just be bypassed effectively, and the schools or offices can do it themselves and go away from our customers. Typical applications are school classrooms, waiting rooms. Like I said, could be for allergy sufferers, so people with allergies, hay fever, asthma. It may reduce those sorts of trigger levels. Depends on the person. Offices, nursing homes, and restaurants. Like I said, school classrooms is kind of the big thing here, but all these other areas are actually still will use this, and they use this type of product all throughout Europe. So waiting rooms in doctors' surgeries and dentist surgeries, where people are waiting in areas, people want to be protected, and so this is a good spot to put them. Office buildings, okay, we might have ventilation systems, but if the ventilation is not sufficient, or you can put these in there and it will help reduce the actual viral levels in the actual office buildings. Nursing homes are a classic one. We all know about COVID transmission in nursing homes. My mother-in-law's in a nursing home at the moment. We haven't been able to see her, I reckon, for 6 weeks because there's been COVID cases in the nursing home, and they won't let visitors in. And in fact, the residents are actually locked in their rooms for that period of time because they don't want to spread it. And so anything which you can do to reduce sort of risk of transmissions in nursing homes is important. Restaurants, places where people congregate is going to be where this unit's going to be helpful. The size of the unit, we use it where we can't increase ventilation rates and use one unit for 56 square meters of floor area. So to select, just find the floor area for the 10 by 8 room, 80 square meters, divide the floor area by 56. 80 divided by 56 is 1.42. Round it up to the nearest whole number, so 1.42 is rounded up to 2. Therefore, you need 2 Cleanair-Skys for an 80 square metre floor area. So it's a very basic selection process sort of thing. It's like I said, we're not talking about airflow rate, we're just purely talking about floor area, and that's all you need to do to actually sort of determine how many units are required for a certain environment. Okay, so pricing and availability. Okay, the target sell price is $3,500. So what Fantech have done is they've discounted the margin to include air freight where required. Now, we're not stocking a lot of these units. Like at the moment, we've only got 4 units in stock. But by having them, but Germany, where these come from, has got 300 to 400 units in stock. So the idea is that we're actually reducing the margin to include air freight. So if the customer wants it, we can get it here in a couple of weeks' time, sort of thing. So if they want 100 units, it's not an issue. We're going to pay the cost of the air freight, and we'll be able to sort of sell that in a quick period of time, sort of thing. So we've got 1 sample unit which we've got available for anybody who wants to show it to customers. So if you want to sort of demonstrate this to a customer, we've got 1 unit available which will sort of ship around to the various offices. The only thing which we'll say is that because there's only 1 unit floating around, we sort of can't have it somewhere for 3 months and just sitting on a bench or something like that. So if you've got some meetings booked, speak to Troy DeVries, who's the product manager, and he'll organise for the unit to get back and get sent to you. And like I said, once you finish your presentation, we'll get it back and then we'll send it to the next place, sort of thing. So we'll need to book that out to do the presentations. But of course, once we get consistent demand for the product, then we'll look at sort of stocking this. But this is sort of a low-risk way of actually sort of introducing a product, air freighting it in at the start, and then once we see what the demand is, we'll look at what stock levels we need to maintain supply. So that's the presentation on the Cleanair-Sky. So hopefully that's given you a lot of the information, the ins and outs of the product. Yeah, I suppose I'll open it up to any questions if anybody's got any. Like I said, unmute yourself if you want to ask any questions.
I'll ask a question, Kerry. Can the filters be in the wrong way?
The G4 filter at the bottom can't be at that rectangular shape. It can only go in one way.
No, the other two
ones, yes, you could swap them around. Now, it won't affect the operation of the unit though, because the carbon filter is still there. The carbon, like I was saying before, the F9 filter is actually not really doing much at all. So it doesn't really matter whether it's closest to the fan or furthest away from the fan. It's not really working, but the carbon filter should be on the outside. It's going to be the actual best performance, and you're going to protect its life a little bit longer. But like I said, the F9 filter is just to protect the carbon filter for a bit longer. It's not actually doing anything for the actual functionality of the unit, so it wouldn't be critical. But we'll have to have a label on there, and there's good instructions to show you how it needs to be done, sort of thing. So but yeah, unfortunately, the filters are exactly the same size. So yeah, technically somebody could swap them around.
So Kerry, you started by explaining about the concern of CO2 levels inside the room.
Yep.
And then you went on to explain that this sort of unit won't do anything to reduce CO2.
Yeah.
So if a school is looking to do both, clean the air and reduce CO2, they're going to have to continue to have a mixture of both ventilation and recirculating units like this.
Correct. Yeah.
Presumably that won't impact the number of recirculators, because you're not likely to be bringing COVID into the building, are you?
No. I mean, you'd say that it's actually sort of, in fact, by adding more ventilation and putting these in, you're actually reducing the risk further, because the ventilation system is reducing the risk, and this is further reducing the risk. So it actually will just add to the reduction. So yeah, more is better in this particular case.
And so that will have no bearing on the ratio of room size to number of air purifiers. It won't increase it, will it? if there's outside air being brought in?
Technically, I wouldn't increase it. I mean, you're probably right. Technically, you might be able to actually reduce it a little bit, but we don't have those numbers. We don't know how it's going to perform like that.
No,
I would stick to the numbers that we've got. Your theory is probably correct, but yeah, I would just stick to that 56 square meters.
No, that was my thought, that we stick to the same numbers regardless of whether it's there's recirculation or outside air.
Well, one thing was asked yesterday was what comes out of the unit, what electrical cable. So it's just actually got a 3-core electrical cable coming out with sort of loose ends. So it's just active neutral and earth, so it's single phase. So like I said, there's no plug on it. The electrician has to sort of wire that in. And it was also a question was also asked about is there a mounting bracket? And what you can see on the top of the unit here, there is actually a mounting bracket which you sort of actually mount to the ceiling first of all, and the unit actually will then just sort of lift up, go across, and then drop down into the mounting bracket. So the whole unit can be mounted very easily to the ceiling as well. So they were just some other questions that came out of yesterday's presentation.
Are there any Australian electrical certification requirements, Kerry, that we need or we've got, or?
No, that there are no requirements for this. Ironically, air purifiers are exempt from electrical certification requirements. So it doesn't mean you can't make them safe, and it has to be safe, and it has gone through the European sort of certification. So we're comfortable with the safety of it. But yeah, an air purifier is actually specifically excluded from the electrical approvals process. So it just means we don't have to go through the testing process again. It has already been done in Germany, but we don't have to do it in Australia. Okay, well, thanks all for your time. If there's no more questions, we'll close it there, but Wayne's going to make the presentation available by video. I know I've gone through a lot of information there, and so if you need to refresh your memory sort of thing, we'll make that available. And if anybody was not able to attend, we can sort of we share that. But yeah, thank you all for your time. Hopefully it was informative.
Kerry, one last thing, mate.
Sure.
What sort of sensible heat is this product creating?
Sensible heat?
Yeah.
Oh, well, the fan only consumes 34 watts of power. So then it's an EC fan, so it's going to be very efficient. So it's probably going to be, I don't know, 70 or 80% efficient would be my gut feeling. So the heat rejection for that's probably going to be 10 watts. I don't know. It's marginal. It's almost nothing, basically. So yeah, I wouldn't be concerned about the heat rejection of this. It's got such a small electrical load that'd be nothing.
Because I'm pretty sure consultant would ask me the first question is, in terms of allowing for the heat load calculation, they need to know what sort of sensible heat this product is creating. You know? So
zero. It's producing zero sensible heat. It's not a heater. It's not producing anything. It's like do we tell people about the sensible heat that a fan's producing? It's a fan, effectively. It's a fan with a filter is really what it is. So it's not heating or cooling the air at all. It's just purely a fan. So it's exactly the same as what would provide for a fan. So it's, yeah, there should be no requirement for sensible heat.
I was just thinking about the plasma, because plasma would surely create a bit of heat.
No, it's something called cold plasma. The sun is plasma, and again, I wasn't going to go into this sort of detail, and that's what you sort of think about as plasma, and so it's millions of degrees Celsius. Obviously, this is not millions of degrees Celsius because you burn the whole building down. It's actually, it doesn't produce any heat, the plasma, so it's actually the zero heat generator, or it's so minuscule that you wouldn't even measure it, sort of thing. So it's something, yeah, it's called cold volume plasma, but yeah, it doesn't generate heat, so you don't have to worry about that.
Thank you, mate. Just one more second, mate. Nikki has a question.
If the filters aren't replaced when they should be,
Yep.
will it then be harmful and start leaking ozone into the classroom?
No, I mean, as long as the filters are present, even if the filters don't get changed, You'd want the actual activated carbon to be changed effectively after 5 years, because if the activated carbon filter does get full, but again you've got the warning message on the side, well then there's a risk that you start releasing some ozone. But as soon as you replace a filter, no, there's no risk again. And again, it comes up with a warning message when you get into the time that you need to change the activated carbon, and it will pre-warn you as well, sort of thing. It's not saying, oh yeah, you get to 2 years afterwards, now you've got a problem. It's telling you when it needs to be done.
Okay.
And is there any minimum ceiling height for this one?
Not really, because you can't get access to anything, but we'd recommend the same as a ceiling fan. Just do it at least 2.1 meters above ground level. You don't want to bump into this, obviously, if you're walking around. If you stick your hand up, there's nothing to come in contact with, so I wouldn't be worried about it from a safety perspective. But yeah, it just makes sense. Don't mount it too low.
No worries, thank you.
Yep.
No?
Kerry, from Oxitec, have they let you know what the uptake of these units are in Europe? Are they selling? Is there hesitation in adapting this type of filtration or technology, or is it pretty much mainstream now?
It depends. I think they're doing well. They're stocking a lot of units, so they've got a lot of stock, so they are certainly selling them. There is the issue with the unit is, and it's got no fault of the unit, it's that plasma, people think of plasma as being something which is introducing nasties into the air, because some people sell plasma units that don't have the carbon filters and they just release all the stuff into the air. And so there's some people think that, oh yeah, plasma is going to be making the air dirtier. But Oxitec units have got all this protection on there to make sure only clean air comes out of it. So the only negative real thing about this is the fact that you say, oh, it's a plasma unit. They go, oh, that must mean that you're releasing the contaminant from the airstream. And so the negative perception about that, because some companies are a bit snake oil and they just go and sell something without all the evidence. So that's probably the negativity. But yeah, there's plenty of people which are very happy with it, and I think they've got a lot of success with it. But yeah, there are going to be the occasional people. You'll speak to somebody who thinks they know everything, and they might go, oh, no, I'm not going to touch this because it's plasma or whatever sort of thing. So it's something to be aware of. The unit is perfectly safe and it's been tested by laboratories, but that's the one negative perception about it.
So if you get that pushback, you can come back and say, well, it has got the right filters inside it to get rid of any of those nasties that would normally be emitted into the air.
Well, you can actually say it's been tested and shown not to actually do that. So that's probably the important thing, because yes, it has got the filters, and you're right, that's what does produce it, but it's been tested to show that it doesn't produce those negative side effects. So we've got, unfortunately for the VOCs, it's all in German, but for the ozone and everything else, we've got English test reports which we can share. So we can actually say, well, listen, we're happy to give you a test report showing you that that's not what happens. Great. Any more questions then?
Thanks, Kerry.
Excellent. Well, thanks, everyone. Enjoy the rest of your day. And like I said, send me an email if you've got any questions that you need answered.
Thanks, Kerry.
Thanks, everyone.
Bye, everyone.